frictionless inclined plane. Onto the inclined plane there is a mass 2 kg and over here there is a mass 3 kg which is vertically hanging, and these two blocks, they are connected by a massless string passing over a pulley. This whole system has been put into a lift elevator which is vertically moving up with 2 meter per second square. We are asked, that is, what are the acceleration of these two blocks 2 kg and 3 kg with respect to the lift. So obviously lift is an accelerating reference frame. We can make use of concepts of accelerating reference frame or non-inertial reference frame, that is pseudo forces concept we can use over here, and we can solve this question. So let's first be clear about the observer. Observer is either you can say reference frame is lift, or let's say for convenience we can say that there is an observer who is standing the lift. So acceleration of lift and acceleration of this person is same. So one thing is, first of all, if he wants to apply laws of motion, he has to take care of a pseudo force. Before that, he has to draw all the forces which are acting on these two blocks. Onto these blocks, this is 30 Newton is over here, m into g. We have taken once again g as 10 meter per second square for the ease of calculation. Over here it is 20 Newton acting this way. This 20 Newton m into g will have two components. One is this way, the other is this way. So this is 30 degree. So this is going to be 20 cos 30 degree, and this is 20 sin 30 degree. Right? We have done it in the resolution of forces, we have done it. So we can remove this 20 Newton because either you can have a resultant force or you can have its components. This resultant force mg has been broken into its components. So 20 cos theta will certainly push it now this inclined plane, and this inclined plane will push it up with the normal reaction. This way there is not going to be any motion. So these forces, they are going to balance each other. So for the time being we can remove these forces. Along the string we have one force 30 Newton this way, 20 sin 30. Sin 30 is half. So this comes out to be 20 into half, that is, so this comes out to be 10 Newton. Apart from this, because this person is accelerating, there has to be this pseudo forces also. Pseudo forces onto this, it is mass of this and acceleration of the lift, that is 3 into 2, 6 Newton is in this direction. Similarly, a pseudo force is also acting on this, also in this direction, that is 2 into 2, 4 Newton this way. Once again, this can be broken into two components. One is 4 Newton component, this way it is 4 cos 30, and this way it is going to be 4 sin 30. We can remove this. We have already broken into components. Once again, 4 cos 30 will increase further the normal reaction. We are not bothered what are the forces acting this way, because it is the block is moving just like this, it is not moving in this direction. So right now we remove this as it clutters the diagram. 4 sin 30, that is sin 30 is once again 1 by 2. So this makes 4 into 1 by 2, that is 2 Newton. So now this person, he has drawn the forces, real forces also he has drawn, and he has taken into consideration the pseudo forces also. Along the string this way, he finds that is 30 plus 36 Newton is acting this way, and this way 10 plus 2, 12 Newton is acting this way. This force is greater than this force, so eventually the system will move in this direction. What is net force along the string this way is, that is 36 Newton this way minus 10 plus 2, 12 Newton is equal to total mass. This resultant force is responsible for accelerating both the masses, that is 3 plus 2, 5 into a 36 minus 12 is 24 by 5 is equal to acceleration, that is 24 by 5 meter per second square is the acceleration of these two blocks as seen by this person. So if you wish to write this acceleration, these two acceleration as seen by this person in vector notation, so what we can do is, we can say that is this is x axis, this is y axis, y dash, x dash. So acceleration of this is this going downwards. We know that this side unit vector is I cap, this side is j cap, downwards is minus j cap unit vector, and this side is minus I cap or I hat or I caret. So this acceleration of this block as seen by this is minus 24 by 5 j cap meter per second square, and acceleration of this block is going to be 24.5 meter in this direction, acceleration of this block is 24 by 5 meter per second square at an angle of 30 degree in this direction. So this can be broken into two parts, components. One is along the x-axis, the other is along the y-axis. So this component of its acceleration along x-axis is 24 by 5 cos 30 I cap, and this component is going to be 24 by 5 sin 30 j cap. So acceleration of this, that is acceleration of block of mass 2 kg with respect to lift, is equal to 24 by 5 cos 30 degree cos 30 I plus 24 by 5 sin 30 degree j cap. This is acceleration vector of this with respect to the lift. If you have to find what is the acceleration of this as seen by a person on the ground, so we know that is how to use the triangle of acceleration, that is acceleration of this plus this, that is we can use triangle of acceleration, that is acceleration of block, we are talking of about the 2 kg block. Acceleration of block with respect to ground, G for ground, is acceleration of lift with respect to ground plus acceleration of block with respect to lift. That is triangle of acceleration. So we have to find this. So acceleration of block with respect to ground is acceleration of lift with respect to ground. Acceleration of lift with respect to ground is 2 j cap. Lift is going up in the y-axis with the 2 meter per second square. So it is 2 j cap plus acceleration of block with respect to lift. We have got it. So 24 by 5 cos 30 I cap plus 24 by 5 sin 30 j cap. You can put the values and you can get the answer. Similarly, we can find the acceleration of this block, 3 kg block, with respect to a person on the ground. So once again, acceleration of block, this for 3 kg we are talking about. Acceleration of block with respect to the ground is acceleration of lift with respect to ground plus acceleration of block with respect to the lift. Triangle of acceleration. So acceleration of block with respect to ground is acceleration of lift with respect to ground, which is that is 2 j cap, plus acceleration of block with respect to lift, it is 24 by 5 meter per second square in the downward direction. So it is minus 24 by 5 j meter per second square. You can solve this to get minus 14 by 5 j cap meter per second square. So this is the acceleration of 3 kg block with respect to the ground.